This video is about experimental design. Number 17. There is a link between the presence of computers in K-12 schools and their standardized test scores. Standardized. Therefore, we should spend more money on computers in schools. Are there any lurking variables in this study? Well, lurking variables are variables that are neither cause nor effect. All right? They are not the explanatory variable, and they are not the response variable. But yet, they have an effect on our interpretation of the results. So, in this little story, we have two variables. We have the presence of computers. That's one variable. And then we have standardized test scores. That's the second variable. And so they're seeing a correlation. I'm assuming the schools that have more computers have higher test scores. So does that mean that the computers are causing the test scores to be higher, or could there be other variables that are more directly involved? So the wealth of the communities would be a source of actually many lurking variables, because the schools with more computers are likely to be more wealthy than the communities with schools with fewer computers. And that leads to things like wealthier families tend to read more with their children, and they can also afford more tutoring. The head of a quality control department at a printing company would like to carry out an experiment to determine which of three different glues results in the greatest binding strength. One factor to consider is whether the book is being bound as a paperback or a hardback. Outline a block design for this experiment and explain why this is the best design to use. The block design is where you basically have two different parallel experiments running, one for each category. So this is going to be the best design to use in this situation because we have two different kinds of books. We have paperback and we have hardback. Alright, we have paperback books and we have hardcover books, and that's going to affect how the glue is going to work in terms of binding strength. So to have one experiment basically running on paperback books and then have a separate experiment running on hardback books, that will make a block design. But let's go ahead and put the numbers to it. So let's make up some numbers. Let's say 150 paperbacks randomly assigned, so three groups, so that'll be 50, 50, and 50. And then those groups will be randomly assigned to the three different types of glue. And in the end, you compare binding strength. So that's one block. And of course, the other block will be the hardback books. Alright, so there's what the full experiment would look like. Obviously, you just duplicate the same thing for the hardback books in terms of the experiment. And again, block design is best in this case because there are two different kinds of books which are known to respond differently to glues. Number 19. Is the right hand generally stronger than the left in right-handed people? You can crudely measure hand strength by placing a bathroom scale on a shelf with the end protruding, I mean sticking out, and then squeezing the scale between the thumb below and the four fingers above. The reading of the scale shows the force exerted. You've recruited 10 right-handed people to serve as subjects. Carefully describe the design of a matched pairs experiment to compare the strength of the left and right hands using these subjects. Well, first I would randomly assign the 10 subjects into two groups of 5 using a random number generator. Each subject in group 1 will perform the squeeze test with their right hand, and then they will perform the squeeze test with their left hand. Each subject in group 2 will perform the squeeze test with their left hand first, and then their right hand. So that's the reverse. In each case, I will compare the left and right hand force of the same subject. I will see what percentage of my subjects had a stronger right hand and by how much. So that is what a matched pairs experiment would sound like. Justin packed 2 suitcases for his trip and compared the weights of the items he packed in each of the suitcases. So we've got these box and whisker plots here. Okay, so in suitcase 1, you can see the distribution of the items and versus suitcase 2. Now, using the graph above, answer the following questions. How much does the heaviest item weigh? Well, these are the weights happening right here in ounces. So the heaviest item is going to be represented by this mark right here. So that's somewhere between like 28 and 32. So it seems to be about 30 ounces. Okay. How much? Oh no, that goes down here. Which suitcase has the bigger range? Well, the range is the highest value minus the lowest value. So the range is going to be reflected by the length of the entire plot from end to end. So suitcase 1 definitely has the longer range. So the heaviest item is 30. The lightest item in suitcase 1 is 4. So that's a range of 26. Looking at suitcase 2, the heaviest item here is 20. And then the lightest item is 2. So subtracting there, that gives us a range of 18. So as you can see, as we knew at a glance, suitcase 1 has the greater range. What is the median weight for each suitcase? Okay, well the median is reflected by the line in the middle of the box and whisker plot. So this is the median of suitcase 1, and this is the median of suitcase 2. Alright, so suitcase 1 has a median of 9, because this 10 would be right here in the middle, and so it's a little bit to the left, so that's going to be 9 ounces. And similarly, suitcase 2 has a median of 7. Alright, because this would be 6 right here in the middle, and it's a little bit over to the right, so 7 ounces. Alright, which suitcase has the majority of its items less than 15 ounces? Well, that's sort of a trick question because both of these suitcases has a majority of items less than 15 ounces. Each part of this diagram represents 25%, a quarter of the items. So we have a fourth of the items here, we have a fourth of the items here, a fourth of the items are here. Okay, that was a horrible fraction. Let me try that again. That's a fourth of the items, and this entire whisker is another 1/4 of the items. So 15 ounces, okay, so right here is going to be 14. Alright, so 15 ounces is about here in this picture. In both cases, literally both cases, both suitcases, more than 75, or we should say at least 75% of the data is less than 15 ounces. Alright, because this is 3 parts of the graph, so that's 75% of the items. 3/4 of the items are represented by this part of the graph. Same here, this is 3/4 of the items right here. So yeah, the majority of the items in both cases are below 15. Alright, which suitcase has a higher spread in the middle, 50%? Well, like I said, each part here is 25%, so the middle 50% is the box of the box and whisker plot. So I've just highlighted the middle 50% for each case, and you can see that suitcase number 2 has the higher spread if you're talking about the middle 50%.